Hi everyone, I'm here to talk about sequences and convergence. Now, why do we need sequences? Sequences are a way of representing information that's similar to a function. So when we have a function defined on the real numbers, we're assuming that we need information about every microsecond. We're having every single instant is continuously filled in, whereas a sequence is discrete. So there are gaps between the measurements. It's just that they're consistently taken. And so a good example of a sequence would be something like a stock price at the end of the day. You don't need to know the stock price at every single second. You might need it every day, every hour, every minute would be okay, but you're not worried about those little millisecond values. So discrete time is at specific intervals. And so we use the notation x sub n, and even though we could, and some people do, write this with function notation, it's more likely to see it with subscript notation to show that this is the value at time n. There are two things you really want to know about a sequence. The first is there a way to find a formula for the sequence? And when we have, say, a formula here, we're looking for something that only depends on the value of n. This is sometimes called a closed form expression or a closed form formula. So an example would be something like x of n equals n squared. Here's an example of a closed form formula. Another one would be x of n equals the sum from k equals 1 to n of k. It's saying add up all the numbers from 1 up to n, and that's the value of the nth term of this sequence. But another way to write a sequence is not closed form. So there are a couple of other ways where you don't have a formula. And one way is what's called a recurrence relation. So in a recurrence relation, you need two things. You need the initial value, and you need a way of generating the next term from the previous term. And a third way that you might see this is you might just have data. You might have a list like at time 0, my sequence took the value 2, and at time 1, it took the value 2.3, and at time 2, it took the value 3.1, and at time 3, it took the value 3.7. And the question is, what is a good formula for the sequence? Now, with this case, you're not going to get something that fits exactly. It's likely that you'll have a gap between your formula and your data, but that's okay. As long as it's useful for prediction, it doesn't have to be perfect. So first I'm going to talk about recurrence relations. A recurrence relation